It is important to read the instructions carefully before we go ahead with solving the paper. In this video, we are going to discuss only the section A. So let us read the instruction regarding section A, which is section A consists of questions from 1 to 18, which are MCQ questions, and question number 19 and 20 are assertion reason based question of 1 mark each. Hello friends, welcome to channel Number Collage. This channel is dedicated to videos on a wide range of mathematical concepts and problems related to them, ranging from high school math to engineering math. Effort has been made to explain the concepts through basic mathematical ideas in a simple English. Hope you will like my effort. Thank you. Question 1. For a square matrix A into adjoint A equals this matrix, we have to find the value of determinant of A plus determinant of adjoint A. Before we solve further, let us understand some basics. Suppose matrix A is, then its determinant is 14, its adjoint is, and determinant of adjoint A 14. What we observe is determinant of A to the power order of A minus 1 equals determinant of A to the power 2, because the order is 2, minus 1 equals this 14 to the power 1, 14, which is nothing but determinant of adjoint A. So we get a result determinant of A to the power order of A minus 1 equals determinant of adjoint A. We can verify this for a 3 by 3 matrix also. Suppose matrix B is its determinant for its adjoint, and determinant of adjoint is 16. Here also we can see that determinant of B to the power order of B minus 1 equals determinant of B to the power 3 minus 1 determinant of B square, which is this 4 square, 16, which is nothing but determinant of adjoint B 16. So this is the result that we use to solve question 1. There is another result that we need to know. We have A equals and determinant of A 14, adjoint of A. Now A into adjoint A equals gives 14 0 0 14, which is 14 into 1 0 0 1, 14 into unit matrix of order 2. So A into adjoint A is 14 into I2, which equals 14, which is nothing but determinant of A into I2. So we have a result matrix A into adjoint A equals determinant of A into unit matrix of the same order as matrix A. We need to use this result also in the solution. We have just seen A into adjoint A equals determinant A into unit matrix of the same order as matrix A. But here it is given that A into adjoint A equals this determinant, which we write 2025 into unit matrix 100 010 001, which is 2025 into identity matrix of order 3. According to this result, we write this as determinant of A into I3. Now from this, we can write determinant of A to be this 2025. Now we will use the first result that we have seen. Determinant to the power of order of matrix minus 1 equals determinant of adjoint A. So determinant of adjoint A will be determinant A to the power 3 minus 1 determinant of A square, that will be 2025 square. Now we have to find the value of determinant of A plus determinant of adjoint of A. So it will be determinant of A, which is 2025 here, and determinant of adjoint of A 2025 square here. So the correct answer option is B, 2025 plus 2025 square. The order of matrix X is 2 by n, that of matrix Y is 3 by k, that of matrix Z 2 by p, that of matrix W n by 3, and that of p by k. We have to find restrictions on n, k and p so that py plus wy will be defined. Before we find its answer, let us understand some basics. If order of matrix A is m by n and that of matrix P is p by q, then this matrix multiplication AB is possible only if number of columns n of prefactor matrix A equals number of rows P of the postfactor matrix B, and the order of the resultant matrix AB will be m into q. Now let's find the solution. Matrix multiplication Py is possible if number of columns of P k is equal to number of rows of matrix Y, that is 3. So we get k equals 3. Next, matrix multiplication Wy is possible if number of columns of W is equal to number of rows of Y, which is 3. Now, sum of matrix multiplication Py plus Wy is possible only if order of matrix Py equals order of matrix Wy. Now order of Py is P into k, which is equal to order of Wy, which is n into k. Cancelling k from both sides, we get P equals n. So k equals 3 here and P equals n here is the correct option. So the answer option is A, k equals 3 and P equals n. We have to find the interval in which function f of x e raised to x is strictly increasing. Fx is e raised to x and f dash x will be e raised to x, which is positive. We know that f is strictly increasing in open interval a comma b if f dash x is positive for each x belonging to open interval a comma b. In this case, if x belongs to open interval minus infinity to plus infinity, e raised to x will always be positive. So the answer option is C, open interval minus infinity to plus infinity. Question number 4. A and B are non-singular matrices of same order. Value of determinant A is 5. We have to find the value of determinant of B inverse AB square. Suppose matrix B is 1, 2, 2 minus 1 and its inverse 1 upon 5, 2 upon 5, 2 upon 5 minus 1 upon 5. Determinant of B will be minus 5 and determinant of B inverse will be minus 1 upon 5. We have to find value of determinant of B inverse AB whole square, which is determinant of B inverse into determinant of A into determinant of B and square of it, that will be determinant of B inverse minus 1 upon 5 into determinant of A, which is given to be 5, into determinant of B, which is minus 5, and square of it, cancelling 5, which is 5 square. So the correct option is B, 5 square. This is true for any two non-singular matrices A and B of order 2 or 3. You can verify this for yourself. Question 5. We have to find value of n such that this differential equation is homogeneous. We rewrite given differential equation as we name this function f of x comma y. Now we will replace x by lambda x and y by lambda y so that we will get f of lambda x lambda y equals. Now if we put this n equals 1, this lambda gets cancelled and what we get is lambda raised to 0 into y upon x log y upon x plus log e, which is nothing but lambda raised to 0 f of x comma y. So since f of lambda x comma lambda y is lambda raised to 0 f of x comma y, we conclude that given differential equation is homogeneous of order 0. So the answer option is B, 1. We have to find x1 by 2 if the points given here are collinear. If the points given here are collinear, then area of triangle formed by these 3 points as its vertices will be 0. So determinant x1, x2 and x1 plus x2, y1, y2 and y1 plus y2, 1, 1, 1 is 0. Solving this determinant, x1 into y2 minus y1 plus y2 minus y1 into x2 minus x1 minus x2 equals 0. x1 by 2 minus x1 by 1 equals 0. x1 by 2 minus x1 by 2 0 minus x1 by 1 plus x1 by 1 0 y1 x2 minus y1 x2 0 x2 by 2 minus x2 by 2, which gives x1 by 2 equals x2 by 1. So the answer option is A, x2 by 1. Question 7. If A is this matrix, which is a skew symmetric matrix, then we have to find the value of A plus B plus C. If A is a skew symmetric matrix, then we have transpose of matrix A equals negative of matrix A. Now transpose of A will be 0 minus 1 2, 1 8 3, C minus B 0. That will be negative of A, 0 minus 1 minus C, 1 minus A B, minus 2 minus 3, 0. By equality of matrices, we get A equals minus A, which implies A must be 0, B equals 3 and C equals minus 2. So A plus B plus C will be 1. So the answer option will be A, 1. Question 8. For any two events A and B, if P of A bar is half, P of B bar is 2 upon 3 and P of A intersection B is 1 upon 4, then we have to find conditional probability of A bar when B bar has already occurred. Now we have conditional probability of A bar when B bar has already occurred equals probability of A bar intersection B bar upon probability of B bar. We will name this 1. Now we have to find these two quantities, numerator and denominator. For that we will make use of the things given. Now P of A bar intersection B bar is P of A union B bar, which is 1 minus probability of A union B. We name this 2. Now we will find P of A union B from the things given. P of A is 1 minus P of A bar, 1 minus half, half. P of B bar is 1 minus P of B bar equals 1 minus 2 upon 3, 1 upon 3. Now by addition formula, we have P of A union B equals P of A plus P of B minus P of A intersection B, which is half plus 1/3 minus 1 upon 4 given gives 6 plus 4 minus 3 upon 12, which is 7 upon 12. So from 2, P A intersection B will be 1 minus 7 upon 12, 5 upon 12. And finally 1 becomes P of A bar upon B bar equals 5 upon 12 upon 2 upon 3, which equals 5 upon 12 into 3 upon 2, 5 upon 8. So the answer option is C, 5 upon 8. We have to find value of alpha if the angle between vectors P bar and Q bar is obtuse. An obtuse angle is greater than 90 and lies in the second quadrant, and cos in the second quadrant is negative. Hence we have cos theta equals P bar dot Q bar upon PQ. If cos theta is negative, dot product P bar dot Q bar will also be negative. Now P bar dot Q bar equals dot, which equals 2 alpha square into 1 2 alpha square minus 3 alpha into 1 minus 3 alpha 1 into alpha plus alpha. That will be 2 alpha square minus 2 alpha into alpha minus 1, which is negative. Alpha into alpha minus 1 negative. That gives alpha belongs to open interval 0, 1. So the correct answer option here is B, 0, 1. Question 10. Mod A bar is 3, mod B bar 4, and mod A bar plus B bar is 5. We have to find mod A bar minus B bar. We assume mod A bar to be A and mod B bar to be B, and write A plus B whole square plus A minus B whole square as A square plus B square plus 2AB plus A square plus B square minus 2AB. Cancelling 2AB, it is 2 times A square plus B square, which is 2 times A square, which is 3 square, 9 plus B square, which is 4 square, 16, 50. Now from this we write A minus B whole square equals 50 minus A plus B whole square, 50 minus 5 square, which is given 25. That gives A minus B equals 5, or mod A bar minus B bar equals 5. Hence, the correct answer option is C, 5. Question 11. For the LPP, the objective function is z equals 4x plus 3y, and the feasible region determined by a set of constraints is shown in the graph. We have to select which one of the following statements is true. The objective function is z equals 4x plus 3y. So the maximum value of z at r 40, 0 will be 160. Maximum value of z at q 30, 20 will be 120 plus 60, 180. Value of z at p 0, 40 will be 120, which is smaller than value of z at r 40, 0, which is false. So option C is false. In option D, the value of z at q 30, 20, which is 180 here, is less than the value of r 40, 0, which is 120, and which again is a false statement. Maximum value of z is at q 30, 20, which is 180, is the correct answer option, whereas value of z in option A is less than that. So therefore option A is false. Hence option B is the correct answer option. Question number 12. We have to find integral of 1 upon x cube into 1 plus x raised to 4 raised to half. Before we solve this integral, let us first consider 1 upon x raised to 5 square root of 1 plus 1 upon x raised to 4, which is 1 upon square root x raised to 10 into 1 plus 1 upon x raised to 4, which is 1 upon square root x raised to 10 plus x raised to 10 upon x raised to 4 x raised to 6, which will be 1 upon square root of x raised to 6 into x raised to 4 plus 1, which will be 1 upon x cube into 1 plus x raised to 4 raised to half, which is same as this function, for which we can write this function. So the first thing that we got here is this given integral equals this integral. Now we can solve this integral by substitution method. For that, we will assume this 1 plus x raised to 4, which is 1 plus x raised to minus 4 equals t after differentiation minus 4 x raised to minus 5 dx equals dt, dx upon x raised to 5 dx equals minus 1/4 dt. So our required integral I becomes, after putting for this dx upon x raised to 5, this minus 1 upon 4 dt, and putting this 1 plus 1 upon x raised to 4 t, it will be 1 upon t raised to half, which equals minus 1 upon 4 integral t raised to minus half dt, which is minus 1 upon 4 t raised to minus half plus 1 half upon minus half plus 1 half plus constant of integration c, which is minus half 1 plus 1 upon x raised to 4 raised to half plus c. That will be minus half into 1 plus x raised to 4 upon x raised to 4 raised to half plus c. That finally will be I equals minus 1 upon 2x square after taking square root of this x raised to 4 into square root of 1 plus x raised to 4 plus c. So the correct answer option is A. There is a printing mistake of not printing minus here. Question number 13. We have to evaluate definite integral from 0 to 2 pi 7th power of x dx. According to rules of definite integrals, integral of f of x dx from 0 to 2a is 0 if f of 2a minus x is minus f of x. Given definite integral is where f of x is 7th power of cosec x and f of this 2 pi minus x will be 7th power of cosec 2 pi minus x, which is minus 7th power of cosec x, which will be minus f of x. Since f of 2 pi minus x equals minus f of x, the value of this definite integral will be 0. So the correct answer option here is A, 0. Question 14. We have to find general solution of differential equation e raised to y dash equals x. E raised to y dash equals x. Taking logs on both sides, y dash log e equals log x. Log e to the base e is 1. So y dash equals log x. dy by dx equals log x. dy equals log x dx. Integrating y equals x log x minus x plus c. So the correct answer option is B, y equals x log x minus x plus c. Integration of log x dx can be found out by integration by parts. Writing it as integral log x dx equals integral of log x into 1 dx. Question 15. We have to recognize the function of which the graph is depicted here. For this function, domain is closed interval minus 1 to 1 and range closed interval 0 to pi. Here in the four options, only inverse functions are given, and we know that cos inverse minus 1 is pi and cos inverse 1 is 0, which satisfy the domain and range. This graph must be of function y equals cos inverse x. So the correct answer option will be B, y equals cos inverse x. Question 16. An LPP along with the graph of its constraint is shown below. The corresponding objective function is z equals 18x plus 10y, which has to be minimized. The smallest value of the objective function z is 134 and it is obtained at the corner point 3, 8. Here we have to select correct option for the optimal solution of the above LPP. From the shape of the feasible region, we find that at the point 3, 8, the linear inequality 18x plus 10y less than 134 does not have any point common with the feasible region. Therefore, for the existence of optimal solution of above linear programming problem, option D is correct, which says the optimal solution exists as the inequality 18x plus 10y less than 134 does not have any point in common with the feasible region. Question 17. We have to check continuity and differentiability of the greatest integer function at x equals 2.5. Graph of this greatest integer function is a straight line for all x belonging to open interval 0.5 minus h to 2.5 plus h, where h is infinitesimally small positive quantity. Hence, we say that f is continuous and differentiable at x equals 2.5. Hence, the correct answer option is D, continuous as well as differentiable at x equals 0.5. Question 18. We have to find area in square units of the region bounded by the parabola x square equals 4y, this one, and the line y equals 4, this one. We have to find this area. Required area is 2 times integral x dy from 0 to 4, which is 2 times integral from 0 to 4 of 2 square root y dy after taking square root of x square equals 4y, which is 4 integral y raised to half dy, which is 4 times y raised to half plus 1 y raised to 3 upon 2 upon 3 upon 2 from 0 to 4. 4 into 2 upon 3 into 4 raised to 3 upon 2, which is 8 upon 3 into 4 raised to half raised to 3, which is 8 upon 3 into square root of 4 is 2 and cube of 2 is 8, which will be 64 upon 3 square units. So the correct answer option is B, 64 upon 3. Question number 19 and 20 are assertion reason based questions carrying 1 mark each. In this, 2 statements are given. One is labeled as assertion A and the other reason R. We have to select answers from the options A, B, C and D as given below. In option A, both A and B are true and R is correct explanation of A. Option B is both A and B are true but R is not the correct explanation of A. Option C, A is true but R is false, and option D, A is false but R is true. Question 19. In assertion A, modulus function fx is defined for x which is real and this fx is not differentiable at x equals 0 and x equals 1. A function is not differentiable at a point when the left hand limit is not equal to its right hand limit. And in reason R, same thing is given to support assertion A that a function defined and continuous on open interval a comma b is not differentiable at x equals c, such as x equals 0 and x equals 1 if the left hand limit is not equal to the right hand limit. Hence, the correct answer option is A. Both A and R are true and R is the correct explanation of A. Question number 20. Assertion A. Odd multiples of pi by 2 where n is integer omitted from the set of real numbers is the domain of function sec x is not 1 function in its domain. By horizontal line test, it cuts the graph of sec x in more than 1 points, indicating that the function is not 1. In reason R, the line y equals 2, this one feeds the graph of the function sec x at more than 1 point, indicating that sec x is not 1. So both assertion A and reason R are correct, and reason R supports assertion A. So the correct answer option will be A. Both A and R are true and R is the correct explanation of A. Friends, if you like this video, please like, share and subscribe this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.